This session is for OCR FP1, the topic is Summing Series, and we're doing June 2011, question 7. So if we start by just looking at the three parts of the question, the first part we're asked to show that 1 over r minus 1 minus 1 over r plus 1 is the same as 2 over r squared minus 1. In part 2 it says, hence find an expression in terms of n for sum up from r equals 2 to n of 2 over r squared minus 1. And in part 3 we've got to find the value of the sum from r equals 1000 to infinity of 2 over r squared minus 1. So let's just take the first part and make sure we can get that correctly. It's the basis of the rest of the question, so we do need to be careful. So we'll take a common denominator of r minus 1 upon r plus 1, and r minus 1 into the denominator will go r plus 1 times, subtract from that, and r plus 1 will go into it r minus 1 times, and that is the same as the r's cancel out and you get a 2 on the top line, and of course the denominator we can express as r squared minus 1. So just one mark for that part, but it is, as I say, the basis, because the next bit says hence, so we do need to use that result. And in really what we're saying then is, instead of finding that sum from r equals 2, then we're going to find the sum from r equals 2 to n of 1 over r minus 1 minus 1 over r plus 1. So we are going to use what we refer to as the method of differences. So we're starting, notice, at r equals 2. So r equals 2, our first term would be 1 over 1, and the next term will be minus 1 over 3. If r equals 3, then we'll get 1 over 2 minus 1 over 4, and you do need to do at least 3. Sometimes it's a better idea to actually do a few more, but at least 3 will be needed so we can see what's happening here. So those are the first 3 terms, and you might sort of suspect that these seem to be cancelling out. If you're in any doubt, then the thing to do is just to take another term, and that of course will be 1 over 4 minus 1 over 6. And then we'll move on towards the end, and we'll start by taking r equals n minus 1. So I'm going to look at the last 2 terms, and if necessary I could always do the term above that. But when r equals n minus 1, then the first bit, r minus 1, then will be 1 over n minus 2, and this will be minus 1 over n. And when r equals n, we'll get 1 over n minus 1 minus 1 over n plus 1. So this is what we call, as I say, the method of differences, and the interesting thing about it is, of course, what happens is that we start to be able to do a bit of cancelling. So that minus a third will go out with that plus a third, and this minus a quarter will go out with that plus a quarter, and so on. So we can suspect that these will all go out, as will this one will go out up here, and this one will go out here. So what we're actually left with is we're left with these 2 terms and these 2 terms. Now you should always find that you're left with sort of same number of terms at the top as you are at the bottom. And so what we want now is we want the sum. So our sum of 2 over r squared minus 1 from r equals 2 to n is then going to be, you've got 1 plus a half, to 1 plus a half, and then you've got a minus 1 over n and another minus 1 over n plus 1. So if we simplify those 2 numbers, we get 3 over 2 minus 1 over n minus 1 over n plus 1. So that now is our sum. And that's the sort of form that we need to give it into. If we look at the marks for that part, just before we move on, then there were 5 marks for that. So you get an M1, a method mark for getting at least 3 terms here, an accuracy mark if you get 2 correct, and another accuracy mark if you get these last 2 correct. You then also get a method mark for cancelling. So I'll just put that in and just remind you that that's for cancelling. And then an accuracy mark for getting the sum. So we then move on to the third part. Now the third part's interesting because we're actually going to be finding a numerical value. So we want to find the value of sigma from r equals 1000 to infinity of 2r squared minus 1. So what we have to think about here carefully is that, if we just write this down, how we're going to do that. We know that we've got the sum from r equals 2 to infinity. We could find that all right, because that's just going to be the sum. That's going to be our sum, which is 3 over 2 minus 1 over n minus 1 over n plus 1. But with that, we'll have to be careful about as n tends to infinity. But from that, we're going to have to subtract the sum from r equals 2 to 999. So that's really the important thing, that you have to do it in that way. So that is going to be 3 over 2 minus 1 over, remember we had 1 over n, so that's 999. And it was minus 1 over n plus 1, so that's going to be 1000. So this is going to be a numerical value here. But here we're going to have to be careful, because as n tends to infinity, each of these terms are going to disappear because they're going to tend to naught. So we're only going to be left with the 3 over 2 here, and then we have this 3 over 2 minus 1 over 999 minus 1 over 1000. And in fact you can see that these will cancel out, and you're left with 1 over 999 plus 1 over 1000, and that turns out to be 1999 over 999,000. So you should give your answer in that sort of form, or you could, if you were doing it in decimals, you could give an equivalent form. But the important thing about that question is seeing that you needed to get your you needed to have this subtraction here. So you got one method mark for seeing that you were going to do this subtraction. You got a mark here for seeing that as n tends to infinity, the sum to infinity is going to be 3 over 2, and then you got an accuracy mark for getting the answer at the very end. And I've given it, as I say, as a fraction, but you could possibly have got away with giving it in terms of decimals. So in total for that question there were 9 marks. So remember, if you want to watch further revision sessions, then you can go to the Further Maths Support Programme website and follow the link.